Hi, I'm Bert. I'm the founder of Tanktwo, and we have here a video that demonstrates the simplest possible version of what could be considered a string battery. Tanktwo makes string batteries for all sorts of applications, including electric cars. Battery packs obviously can be very large. So when we go around and do demonstrations, we've been asked to do it with the simplest possible version that we can build, and that's this. So this setup consists out of basically two parts or three parts. So one is the tube, which is nothing else than a passive translucent container with two contact terminals on the extremities, the actual string cells themselves, so the X-shaped devices that contain the energy, and then the user interface, which is essentially a tablet but then thicker. So this video is unedited except for some alterations in speed to make it a little bit more interesting, but no cutouts or no modifications otherwise. So this is how the demonstration goes. So an operator, in this case Tanktwo engineer, fills the tube with string cells. So there's no specific orientation of any kind. That is actually one of the core concepts of the string cells, is that the cells are packed randomly, and the software is smart enough to figure it out. Here what you see is that the engineer is agitating the tube a little bit, which is normally done by an automated process, but well, since this is as simple as possible, you need to do it by hand. In the user interface here you can see that the process starts off by actually trying to figure out which cells are in the tube and how they are oriented relative to one another. And this is done by sending a series of impulses through the tube, which all the individual cells sample and then are correlated to make it work. So there's a series of things that happen to collect the information, but all this is transparent to the actual end user. So there's a lot of data that is being collected to make this possible, and it is happening in several iterations, and actually a little bit paradoxically in this incarnation where you have actually the smallest possible string battery. This is a more complex problem mathematically than it can be in a regular sized battery pack, and that is because the opportunities here for creating contacts is much more limited. But nevertheless, the algorithms are flexible enough to deal with anything, and it's a good illustration of how it works. So here, this image which was flashing by is a visual representation of the map that has been created based on the contacts and the paths that had been discovered. A certain amount of optimization is done to figure out if this is actually serving the actual need right now. And what you see here on this display is a set of information that tells something about the actual circuit that is going on, including the temperature of the individual cells, the output current, the number of cells in this string, and then the series voltage. So in this case, the series voltage is 44 volts. Since there's no electronics involved here, so this is the actual voltage which also the load will get. We have the option to have tanks with DC-DC converters, which allows for essentially any voltage to be created independent of the actual string voltage. So the demonstration which is sent to customers is identical to what you see here. So we're going to repeat the process. So where all the string cells that were delivering power so now are essentially shuffled around, put back into the container, and the process is restarted. And if you would look at the data very much in detail, you would see, of course, that the results of the measurements are going to be completely different, but the output, of course, is going to be the same. It's possible actually in this case that because one or more cells or less can be put into the string, so therefore you can actually have a higher or lower bus voltage. Again, in normal battery pack, not an issue, but in this simplest possible form, this is one of the variables that we have to live with. Process again, exactly the same. Initial measurements based on pulses of electricity sent through the pack or through the tube in this case. And the algorithm does all the hard work of making sense of the data that the individual cells are spitting out. So the sequence generally is first initial measurements, collecting data, mapping is creating a logical map that describes how the cells touch one another, and then a routing algorithm is used to determine how the cells actually should be connected, because what you'll see is that there are always more options, more than one option, to hook the cells up. And if you have a regular size battery pack, anything essentially about 10 liters or bigger, the amount of options that you get really skyrockets. So it's essentially almost infinite. So again, these demonstrations here, they are available for customers themselves. So there we have the three-dimensional representation of the data again. And the optimization process starts right now. And again, when that's complete, power out, which is essentially the command that sets all the candies into action, is given. So that is essentially everything there is to it. So this is on purpose not very polished. This is on purpose not accelerated. So what you have here is absolutely the minimum possible demonstration of the Tanktwo technology. You can power a car with it, obviously, but it can power a load that is not sensitive to the output voltage. Actually, we see here that now the cell configuration led to 51 volts, which again is fine, and in a normal application the variance of the voltage can be specified by the customer. So if you want a load that is happily with a range from, for example, from 300 to 320 volts, that's what you can get. If you can live with a wider tolerance range, that's fine as well. It's just a matter of making sure that the customer specifies exactly what this application requires, and the system is then dimensioned accordingly. So this was that. If you want to have a demonstration in person, get in touch with any of us. My email address and phone number is going to be at the end of the video. So just give me a call, send me an email, and we're happy to send you one of these things. Thanks. Bye.